Welcome to an overview on the current trends on Linux on the mainframe. My name is Philipp Brune from Neu-Ulm University of Applied Sciences. In recent years, Linux has become more and more important on the mainframe platform and also is highly supported, and new features are added by IBM on the mainframe platform. So Linux now is a real strategic operating system for the modern mainframes, and in recent years, since the Z13 generation, IBM also started to market the mainframe in particular as a high-end Linux server, and they added a second branding and a second production line called Linux One, which sort of sells the mainframe hardware under a different brand name, Linux One, to Linux-only customers. So this is really positioning the platform as a high-end Linux-based server environment. And in combination with this launch of the Linux One platform, also some new features have been ported to the Linux on S390, as it is called, on the mainframe hardware. And among these is KVM, which was not available before, at least not completely available before, and is now also a strategic option on the mainframe hardware. KVM is the so-called kernel virtual machine, is a concept that has been introduced in the Linux kernel for some years now, and is also standard part of the Linux kernel. It's an integral part of the Linux kernel on most operating systems that the Linux supports. And so it's a standard feature of the mainline kernel. And it basically provides a para-virtualization mechanism that is by default built into the Linux kernel and allows to virtualize or to run virtualized guest operating systems by using para-virtualization on the Linux kernel, where the Linux kernel then serves as a kind of a hypervisor. The concept of para-virtualization requires that the guest operating systems are modified and adapted to be run in a virtualized environment, which is of course especially possible if you have Linux on Linux, so you have an open source system on another open source system. And in this setting, it became very popular. And the basic idea is, as you can see it here on the diagram, on the figure, you run a mainframe hardware, which can be a set system, so a full mainframe, or the Linux One version, which is only equipped with IFL processor, so it only runs Linux. And on this you run, first of all, you run a Linux kernel, and you run it, for example, in a logical partition. And then you use the KVM, which is a standard part of this Linux kernel. And on top of it, there is a layer that is basically provided by the QEMU environment, which is a original emulation, open source emulation environment for different hardware architectures. But for KVM, it serves as a kind of not a full emulation, but as the layer for emulating only for example, the I/O devices. And on top of this, you then run Linux guest systems, virtual Linux guest systems with their own kernel, which of course is a kernel that needs to be capable of to be run on this KVM layer. Okay, this is the idea of para-virtualization. And since Linux, of course, is prepared for that, you can run, for example, Linux guests easily on the Linux virtualization host. And administration tools are provided by something called the libvirt, and there's the vir SH, the vir shell, which provides command line tools to create and stop and start the virtual guests and so on, manage the virtual guests. And all these together provides a full-fledged emulation, and not emulation, a virtualization environment in which a big number of virtual guests can be run on a Linux host. And it's a fully open source based environment, so you don't need any kind of virtualization system like, for example, ZVM, which was the typical solution to virtualize Linux guests or Linux host Linux guests so far. It also still is used in many environments. With KVM now there's the option to have a full pure open source virtualization environment on the mainframe hardware. Okay. And this of course is especially interesting for companies who really want to have a Linux only environment, because it allows also to administrate this virtual environment with normal Linux skills. You don't need to have a special ZVM or mainframe skills to run Linux in this style on a mainframe hardware. A second concept that is immensely popular at the moment and is probably one of the most important foundations for the boom of cloud computing environments and solutions that we have today is containerization. Containerization is a more lightweight virtualization approach, and it plays also a big role on Linux on the mainframe. And the most popular containerization solution is the open source Docker and Docker environment and Docker daemon, which is probably the most widespread solution. Not the only one. There are other containerization approaches like Linux containers, for example, but Docker is by far the most important one. And of course, Docker is also supported on Linux on System Z and Linux One. It is also supported on virtual guests. So you can see it here. In a containerization environment, you have one Linux kernel, which can be either a virtual kernel, a virtual guest system, or on bare metal, doesn't matter. And this Linux kernel then hosts a number of, can be a large number of so-called Docker containers. Docker containers is an application virtualization approach. This means that the containers look like virtual guest machines, but in fact they do not have their own kernel. So they are not really virtual operating systems. They just are containers around usually one or a few applications that are bundled together and that are provided with their own environment, in a sense that they have their own file system and their own I/O structures and so on. But this is just a container in a sense that this environment is not using a separate kernel. So all Docker containers run as processes on one common host kernel. So in fact, these are just encapsulated applications that run in user space like you would have multiple applications running on a kernel. So the idea is that you can encapsulate applications, provide them with their own configuration, with their own I/O settings and so on, and they feel like they run on their own server, but in fact they are all running on a single instance of the operating system. This, of course, is a very lightweight approach, since there's no need to run multiple kernels, and the isolation between the containers is handled by concepts inside the Linux kernel, which are standard concepts of the Linux kernel. On top of Linux, there's the so-called Docker daemon process, which manages the containers and starts and stops the containers, and it runs then the lightweight containers. A container is started from an image, which is managed by the Docker daemon. An image is basically a file system image that resides on disk, and then you can start a container, and Docker calls it a container when it runs. So every container is sort of a running image. And the image can be easily moved from one machine to another. It can be downloaded. There are repositories on the internet where you can upload and download ready-made images, so you can just pull them and launch them on your Docker daemon. And this concept is now available on Linux on the mainframe for some years as well, and it provides the possibility to use this mechanism, for example, for managing lightweight cloud instances and things like that on the mainframe environment as well. Containers play an important role in the context of microservice architectures and microservices. Microservices, the idea is in microservices that you have, or that you break up large-scale applications into various microservices that on its own, they are self-contained in a way that they have, every microservice has its own database, its own application server, its own logic, And the idea is that one microservice is maintained by a team of developers, and if you use a so-called DevOps style, they also are responsible for running and maintaining the production container, and to have that packaged in a easy deployable way. The typical tool are Docker containers. So this is very important for modern microservice-based architectures. One additional feature that is unique to the Linux One and the Z Systems environment under Linux are the so-called secure service containers, which were introduced together with the Z14 generation of mainframes. And these secure service containers are a concept that allows to run Docker images that are extremely critical or that need a high level of protection in a way that the image itself is encrypted on disk, but it is also encrypted in main memory when it's loaded, when it's running. And the new features of the processors, of the Z14 processors, which are called pervasive encryption, allow to encrypt data and from when it is loaded in the CPU on the fly without loss of application speed. This has been reached by largely increasing the number of transistors on the chip that have been dedicated to encryption facilities and cryptographic facilities. And therefore, these processors can encrypt and decrypt the data on the fly. So the idea is that you run in this so-called secure service container, you run basically Docker images that are encrypted. So it's a sort of an extension over the normal containerization approach. And the idea is that an application is packaged into like a kind of an appliance in a ready-made image, and then this image is stored and run encrypted and by a secret key, so that even the administrator of the mainframe, the system administrators, are not able to sort of look into the data or the things that are processed in such a secure service container. So this is extremely interesting for very mission critical and very highly secure applications. The basic idea is that a secure service container is a Linux-based kind of appliance that is installed into a dedicated LPAR and is fully packaged, and then inside this secure service container these encrypted images can be run and loaded without the need that an administrator may look into them. And this way of self-contained Docker structures is used to manage that, because a ready packaged Docker container typically should not require any kind of console or shell access, SSH access to the running machine, virtual container machine. And that is prohibited also in such kind of secure service environments. So secure service containers run in a dedicated LPAR and can run, of course, side by side with other operating systems, which is a special version of Linux running that basically runs this Docker or this containerization solution. And then we have, by hardware support, we have this key management for pervasive encryption. And this kind of hosting model, of course, is interesting for cloud providers, where you want to make sure that the cloud provider cannot see the data of the customers. And it's also especially interesting, for example, in the context of blockchain applications, because blockchain applications typically are critical. They are require trust and these things, and is also based on cryptographic facilities. So finally, in recent years, the topic blockchain has become very interesting in the context of mainframes, because the mainframe is a very well-suited platform to run blockchain applications, especially due to its cryptographic capabilities. And so let's have a short look on blockchain as well, which is probably going to become an important topic in the mainframe world in the future. A blockchain basically is called represents something called a distributed ledger. So it's a journal of operations that is stored in a way that you don't need a central instance that all parties trust. So basically it allows to store in a trustful way, distributed way, trustfully store transactions that have been executed by different parties that together form any kind of business-related network. The original idea comes from Bitcoin, cryptocurrency, that has been proposed by Nakamoto. This is a sort of pseudonym of an unknown person, and it was sort of proposed in context of Bitcoin. Bitcoin works in that sense that you have a distributed ledger, that there is no central party that all parties need to trust. And this basic idea can of course be transferred to completely different business scenarios. Basically, blockchain is an interesting thing always when you have different independent parties that have to have a common understanding and that trust a central thing, concept or object that all parties have to access, that all parties have to modify, and that these modifications have to be trusted by all parties. In the past and today, typically this is handled by having a trusted third party, kind of a notary that is sort of responsible for keeping this journal or this ledger for all the parties. And this is a typical situation where you have intermediaries in business, like for example brokers and things like that. And blockchain now may provide a concept to sort of remove the need for these kind of trusted third parties in different types of business-related activities. Nevertheless, of course, this is at the very early beginning now. Not many applications have been successfully launched, but the idea is very promising. And the basic idea is that you use cryptographic facilities or cryptographic concepts, in the case here of hash functions, to actually store the ledger in a chain of blocks, as it is sort of sketched here. And the idea is that you have some transaction data in every block. For example, in Bitcoin, this is the change of the amount of money in your wallet. And you have hash values of this data. And every block points to a previous block and stores the hash value of the previous block, and then calculates a new hash value, including the hash value of the previous block, and puts this to the next block. So the longer the chain is, the more expensive in terms of computational power it would be to make modifications. So because you have to sort of recalculate the hash values, and by making some additional requirements on the hash values, you can make it difficult and more difficult to manipulate or change the data. So the chain can be trusted and can be checked by the hash values. And that makes it possible that all parties keep a copy of the chain and are able to validate any new transaction that is added to the chain. That is the basic concept of a blockchain. And this allows the implementation of these kind of distributed ledgers. And for the mainframe in the future, this probably will be a very important workload, because the mainframe hardware, especially under Linux, provides a good combination of cryptographic facilities and the possibility to use the standard open source tools. And there's the so-called Hyperledger framework, which is an open source project, highly supported by industry, that provides the basis for implementing blockchain applications also on Linux, on system set and Linux One. So this is a very interesting workload that should be kept on mind, especially in the context of the future, or looking at the future of the mainframe platform. Thank you very much.